Hey guys, welcome back to the QST channel. Today we are going to be solving section 3.22 to section 4.6 for physics periodic level L course questions, which are most likely to come in the written part, and this is for non-transition year. Okay, let's get started. For the first question, a marble moving to the left with a speed of 0.3 meters per second collides with another marble having half its mass. Underline it, half its mass, it's really important. Moving to the right with a speed of 0.8 meters per second, the speed of one of the marbles is half. Determine the speed of the other marble. Here I already pre-wrote the rule here for this question. Mass 1 times velocity 1 before the collision, the velocity before the collision, plus mass 2 times the velocity before the collision is equal to mass 1 times the velocity after the collision plus mass 2 times the velocity after the collision. Okay, so here immediately we are going to say that since it's going to the left, it's going to be with a speed of 0.3 meters per second. This is going to be in the positive sense. So mass 1 times, mass 1 times 0.3, okay, and plus mass 2, 1 over 2 mass 2. They said here half its mass, times negative 0.8, because it's going to be moving in the negative sense, will give me the speed of one of the marbles is halved, okay? And so it's going to be mass 1 times negative, since they're going to be bouncing in the opposite direction now, 0.15 plus 1 over 2 m2 u2. Okay, so now the first thing we can do here is cancel out the mass, because it's everything here is multiplied by the mass. We can on this side remove the mass, and remove the mass here as well as here. So now we simplified the equation. 0.3 plus 1 over 2 negative 0.8 equals negative 0.15 plus 1 over 2 u2. Okay, so now we simplify here. 1 over 2 over 1 negative 0.8 over 2 is negative 0.4 plus 3, that's going to be 0.1, negative 0.1. And here we can move this to the other side, 0.15. So this side here is going to be negative 0.05. And here we have 1 over 2 u2. We can do is multiply by the reciprocal. Multiply this here by 2, cancel this, and multiply this here by 2. So u2 is going to be equal to 0.1 meters per second, because when we moved here the negative 0.15 here was negative 0.15. When we move it there, it's going to be positive 0.15 plus minus negative 0.1. That's the answer for this one, 0.1 meters per second. Consider a bullet ready to be fired. Okay, so here they want what is the linear moment of the bullet before it was shot. They said here a bullet ready to be fired, which means it was at rest, it wasn't moving. So the linear moment of the bullet before it was shot is 0, since it was at rest. Okay, assuming the bullet fired with the velocity v, what will its linear momentum? Momentum is equal to mass times change in velocity, which is there's two formulas for it, which is slash impulse is equal to, or here momentum, mass times change in velocity, or force times change in time. But here they give us the velocity and mass. So you do 100 meters per second times 5 over 1,000, because you need to convert it to kilograms. Sorry. So the answer is going to be 0.5 kilograms on Newton, per meter per second. Okay, that's going to be the answer for this one. And the principle of conservation of momentum, it's basically just memorization. When two or more bodies interact, as in a collision or an explosion, the total momentum of the bodies remain constant, provided no external resultant force is acting on them. It's just memorization. And for question 46, okay, we use the same rule, okay? M1 V1 plus M2 V2 equals M1 U1 plus M1 U2. Sorry, M2 U2. A car moving of a mass of 800 kg moving at 25 meters per second collides with a small truck of a mass 1,200 kilograms moving in the same direction at 15 meters per second. That means they are both equal. So not equal, they're both in the positive sense. So what we're gonna do here, 800 times 25 plus 1,200 times 15 equals, they want the velocity after the collision. They're going to be combined and move with the same velocity. This is really important. So we can do 800 VU, plus 1,200 U. If you plug it in the calculator, 1 second, let me just fix it up. If you plug it in the calculator, 800 times 25 plus 1,200 times 15 equals 800x plus 1,200x. So here we're gonna get the velocity is equal to 19 meters per second, and it's going to be in the positive sense. That's really important because they are both in the same direction. On to the next. So 47. A rocket engine exerts an upward force of 5 times 10 to the power of 4 newtons for 4 seconds. What is the impulse of the force exerted by the engine? Here, impulse, it has two rules. Impulse is equal to force times time, or T, and impulse equals mass times change in velocity. Here we have the mass and time. So what we are going to do is 5 times 10 to the power of 4 times 4. You're gonna get 2 times 10 to the power of 5 newtons per second, because 5 times 10 to the power of 4 times 4 equals 2 times 10 to the power of 5 on per Newton on meter. Okay, easy. On to the next. So the next one here, we use the same rules up here. Impulse equals force times time. Impulse equals mass times change in velocity. Here we want the velocity after 3 seconds. First thing we can do is we find the impulse, okay? Impulse here we use force times time. Okay, so 20 times 3 equals 60. So the impulse equals to 60. So 60 equals 10 kg times the velocity. So it's going to be 60 equals 10v. So 10v over 10 over 10. Velocity is equal to 6 meters per second. That's it. Now we're going to be moving to chapter 4.1. Or let's do this question first. In this question, they want using a scale of 1 centimeter per Newton, make a scale drawing to show the resultant force on the block. Okay. First thing we do is we need to put the normal and weight. Firstly, this is the weight. 1 second. This is weight. And since it's 10, we're gonna use that. And normal is 6. We're gonna do that. So this is the normal and this is the weight. They want the resultant force. First thing we do is make this a triangle. And we can use sine here for the vertical component. And we know that weight is 10 newtons and the normal is 6. We use the 10 here. You do 10 sine 53 vertical equals vertical is going to be 10 sine 53, which is the resultant force over here. It's going to be 7.98. If you round it to the nearest decimal, it's going to be 8.0. So the resultant here is 8. And we found the magnitude and direction of the force on the block here. We drew it already. Now name 2 scalar quantities. Okay, for scalar quantities, one of which is time and mass. It's really simple. Scalar is time and mass because they don't require direction or whatever. But vector, they require direction because time and mass, they can't be negative. But velocity and momentum, they can. So vector is velocity and momentum. The moment of a force, okay, the quantitative measure is the quantitative measure of the turning effect of a force. Okay, so it is the quantitative measure of the turning effect of a force. Okay, the moment is the quantitative measure of the turning effect of a force. Okay, they ask for what is the magnitude of the moment of a force around the pivot. Okay, the moment of a force is m equals force times perpendicular distance, and a pivot is an axis of rotation. an axis of rotation. Okay, on to the next. This one might seem really tricky, but it's easy. The moment of each force, or each of the forces shown in the diagram, first about point A, then point B. So what they want is the net, not net, like each of the forces, okay, about vertex A, like the axis of rotation A, and then we do axis of rotation B. First thing I can say, since force 2 and force 1 intersect the axis of rotation, they're equal to 0. First thing. And force 3, it's like going like this, okay? So it's already perpendicular to the axis here, which is 3 meters. So force moment equals force times perpendicular distance. So force 3, it's going to be 30 times 3. So moment of force 3 on A is 60 newtons. Okay? Per meter. I forgot to add per meter. And moment of force 4 on A. I forgot something really important here. To check if it's clockwise or counterclockwise. But since here I don't think they ask you about clockwise or counterclockwise, but let's do it anyway. Force 3 using the right hand rule, or just draw a diagram, axis of rotation, or use your pen. Make a force like this. It's going to be moving like this, which is counterclockwise, positive. Okay? And for force 4, okay, it's going like this. It's already perpendicular. So 10 newtons times 7. Because you want the distance, perpendicular distance from A to C. Or to like from the force to A. It's 7. 7 times 10. Because from here to here is 7 meters. So it's going to be 70 Newton per meter. We need to check if it's clockwise or counterclockwise. Here it's going to be clockwise, so it's negative. But in the answer sheet, they don't ask for, I don't think they ask for the direction. But in the exam, just to be sure, put the direction, please. Put the sense. It's going to be negative 70 newtons per meter. Now we go for point B. First thing I can say, force 3 intersects with point B, so it's cancelled. It's Z equal to 0. And force 2, okay? Let's go to force 4. It's already perpendicular to point B by 2 meters. So it's going to be moment of force 4 on B equals to 10 times 2, which is 20 newtons per on meter. Now we do force 2. Moment of force 2 on B is equal to, since it's perpendicular here, it's going to be 20 times 5. So it's going to be 100 newtons on meter. Okay, and we forgot to check if they're clockwise or counterclockwise. For B, it's going to be clockwise, negative. And for force 4, and for force 2, it's going to be negative as well, clockwise. Since look, it's going to be moving like this, clockwise, and it's going to be moving like this, clockwise. Okay, so now we need to find force 1. Okay, so what we're going to do is use the Pythagorean theorem. We need to find this, which is going to be the height, and this is the hypotenuse. So we're gonna use 5 squared equals 3 squared plus HB squared. Plug it into the calculator, you're gonna get 4. So HB is 4. So what you're gonna want to do is a moment of force 1 is a moment of force 1 on B is going to be equal to 15 times 4, which is going to give us 60. So it's going to be 60 newtons on meter. Let's check if it's going clockwise or counterclockwise. Wait 1 second, I drew it wrong. Yes, here. It's going to be moving like this. So it's going to be going, if you hold the pen, still going to be moving like this. So negative clockwise. That's easy. On to the next. Okay, they want to determine the magnitude of the moment force F around D. Okay, so this is the axis of rotation. Immediately we can say that this is perpendicular, because the force is going to span out like this. Okay, it's perpendicular to D by 30 centimeters, because this is going to be 30 and this is going to be 60. Here they ask for, if they don't give you a value, don't assume it is newtons on centimeter. Always assume it's newton on meter if they don't ask you. So what you're going to do here, moment equals 4 newtons times 30 over 100. Or sorry, 60. I'm sorry, 60. Because the distance between C and D is 60. So it's going to be 4 times 0.6. So the moment of force F on D is 2.4 newtons per meter. That's it. On to the next. Here immediately I can say this is 0 because it's intersecting with the pivot. Okay, so first thing we need to find is 1, 3, 2. We only need to find one of their values. Then we know, because they're all in the same direction. But if they're like in different, if the point axis of rotation was different in a different point, and they're in different, you need to find all of them. Firstly, you check here. It's going to be going downwards, this force. So it's going to be moving clockwise for 1. For 3 as well is going to be moving clockwise, and for 2 as well, clockwise. So 1, 3, and 2 is and 2 are negative. 5, let's see 5. It's going to be going like this. So it's going to be counterclockwise, so 5 is positive. Okay, simple. Let's go to the next. Okay, this one is easy as well. What you need to do is moment equals force times perpendicular distance. Okay, so the force is going to be going like this. Look, since this is the axis of rotation, the force is going to be going like this, which is counterclockwise, positive. So it's going to be force times distance, 3 times 2. Moment of force F on O equals to 6 newtons on meter. Here we can see that it's going to be going like this, which is clockwise, negative. 2 newtons times 2 meters. Moment of force on O, force 2 on O is going to be equal to -4 newtons on meter. Alright, on to the next. You can draw it as I explained. So here it's better to use the right hand rule. The moment of the force is going to be directed into, because it's going to be clockwise. Look, the axis of rotation, I put a force like this. It's going to be going clockwise, which is negative. And counter and clockwise here. You need to remember this. Counter is positive, clockwise is negative. Counter is outwards and clockwise is inwards. Counter like outwards and inwards have their own sign. Outwards is this, inwards is this. You need to remember this for the exam. Alright? Okay, here is simple as well. You're going to have to add the two moments. Okay? You need to find the net moment here. So here for the first one, it's simple. They're both counterclockwise, as we can see. First one is the distance between it, the perpendicular distance between it is 2 meters. So 2 times 3. Second one is clockwise, counterclockwise as well, so it's going to be plus 2 times 3 because the distance from here to O is 3 meters. Which is going to give you 12 newtons on meter. Alright, now let's go to the next one. It might look like a bit complicated, but it's easy. So here, it's going to be going like this. Look, clockwise, and this one's going to be going counterclockwise. The distance from this is 1, so it's going to be -1 since it's going clockwise. -1. Plus, since this is going this is going, my bad. This is going to go clockwise and this is going clockwise as well. So what we're gonna do is calculate the moment, which is 2 here, and the distance between that and point O, perpendicular distance, is 2. Plus -4, since both of them are clockwise. So this force B is -5 Newton per meter. Okay, let's go to the last chapter. Okay, the characteristics of the forces that form a couple. All you need to know is they have equal in magnitude and opposite in direction, and they are always parallel. Okay, this one, it's easy, but it's going to take a long time to solve. Okay, so here what we want to do is find the net moment. So the net moment of the two couples is 0. Okay, so this is going to be R, and the small one inside here is R. R over R is equal to 5/2. Okay, so now they want this force here, they want this force, and we need to make sure they make it 0, net force 0. Here we can you put your hand up, act like it's a steering wheel, move your right, like steer it to the right. Your right hand will go to the right and your left hand will go upwards to the left. So it's going to go to the left. So it's going to be moving clockwise. It's going to be moving like this, clockwise. So it's going to be negative. Okay. And the distance between those two forces is 2r. 2 small r, sorry. So 2r times negative 200. Plus or minus, let's see, we move it. Make a steering wheel, hold a steering wheel in your hand, push your right hand upwards and your left hand downwards. So you're going to be moving counterclockwise, so it's going to be plus. Let me just write it better. 400 r plus the distance is going to be 2r f equals 0. Okay, so what we can do is 2rf equals positive 400 r, because it was here negative, we moved it to this side. Okay, now we want force. Okay, so we do over 2r. So now over 2r, we get F equals 400 r over 2r. Divide 400 by 2, it's going to be 200, so it's going to be 200 r over r. And previously we got a ratio here, big R over the small r equals 5 over 2. Since now we have r, small r over big R, we can flip it. We can say r over r equals 2 over 5. So we substitute it in here. We get force equals 200 times 2 over 5. If you put it in the calculator, 1 second. You put in the calculator 200 times 2 over 5. Okay? You get 80 newtons. Okay, that's the answer. That's it. It's really simple. You're gonna get 80 newtons. That's it. I hope you guys enjoyed and understood from this video. I hope you guys have the best of luck with your exams. And please study well for your exams and have a great rest of your day and night. And don't forget to like and subscribe.